Hi folks, we're looking here at an uncertainty plot of asteroid 2012 Ka. This particular plot was generated using sampling of Monte Carlo solutions, observational Monte Carlo, and we only have 12 astrometric observations of this asteroid at the moment. So if you go to JPL's website, you'll notice that it's condition code 9, meaning highly uncertain. Basically, more observations of this object are needed to nail down the orbit. But we can look at the data that exists and find out exactly where it will be during its close approach to Earth, or at least where it could be. Each of these blue dots you see here in this line represents a potential position of the asteroid. And as we move through time, we're starting here. This particular simulation starts at the beginning of May 16th, 2012 at midnight Universal Time. And I'll fast forward it here to May 17th. You'll see this line, it's starting to approach the Earth and the Moon. Now it's of course important to consider the three-dimensional aspect of this approach, so we can pan it around here. Frames per second isn't too great because we have so many asteroids being rendered at once. I'll zoom in here on Earth and the Moon a little bit so you can see it better, and rotate it around so you can kind of get an idea of how this happens in 3 dimensions. Looking here, roughly level with the ecliptic, and then from above you can see this is about the time point where it starts to be at its closest point to Earth. Of course, it depends on exactly where it is. It could be anywhere in this region where these blue dots are located. And it's important to note, though, that an impact is not a possibility for tomorrow. We don't know exactly how close it'll be or exactly when it will be at its closest point, but we do know that in this region of uncertainty, there's no risk of an impact with the Earth or the Moon. The two don't intersect. If you look at an actual impact threat, you can actually see that the Earth starts to get pummeled with blue dots. And we'll be talking about that a little later. I'm currently preparing an analysis of 2011 AG5, which is a real impact threat for the year 2040. But for this asteroid for tomorrow, there is no impact threat, not even to the Moon, which, as you can see, is way off in the distance, even farther than the Earth is from this asteroid. I did hear some people talking about, well, what if it comes from behind the Moon? Well, it's not coming from behind the Moon, and in any case, we already have enough astrometric observations to at least rule out an impact in the immediate future, meaning tomorrow. But if we want to keep track of this asteroid in the future, more observations are going to be required to be able to determine its exact orbit and where it will be in the future. But you can see the uncertainty plot is somewhat scattered here because, as I say, we only have a dozen observations. It's not a whole lot of information to go on, only enough to get a general idea of its approach and whether it's going to hit us right now or not, which it's not. But who knows, maybe I'll point a scope over at it and see if I can collect some data myself on it. But that's about it. It's a fairly small asteroid. The absolute magnitude is magnitude 28.8. If you do the math on that, you find out that even if it's a very dark asteroid with an albedo about equivalent to asphalt of 0.05, it's still only a 10-meter rock, so not a big deal. And that's also why we only just now discovered it. It's a very small rock, so you can't see it until it gets close to you. Larger objects can be seen farther away. So that's all for now. Have a nice day.